Well, now we have a paragraph based on which some questions have been asked. Let's read the paragraph. It says a uniform plate of mass m having equilateral triangular cross-section of side length L is placed at the edge of an obstacle inside a cart which is made to accelerate rightward with constant acceleration a0 as shown. An obstacle can apply reaction in horizontal direction only. Well, this is the diagram. This is the obstacle. This is the triangular plate. Now, on the basis of above information, answer the following question. Force F is applied horizontally at the apex of plates to keep it in equilibrium. Question 11 says, assuming applied force F to be 0 and N1 and N2 as a normal reaction on the left half and right half of the plate, choose the correct options. Option A is about N1 is not equal to N2. Option B is N1 is greater than mg by 2. Option C is N1 plus N2 is mg. And option D is N1 is equal to N2. Okay. So it's given that F is assumed to be 0. Right. There's no force being applied, but the acceleration A0 is there. Now, if I draw free body diagram of this plate from a reference frame attached to the cart itself, then we have through the center of mass pseudo force ma0 towards left and of course mg vertically downward, and additionally there is normal reaction on the left half which is n1 and on the right half which is n2. Well, for vertical equilibrium it's very clear that mg is equal to n1 plus n2. So I'm not drawing n1 and n2 as of now. We don't know the line of action of n1 and n2, so that's why I'm not drawing. But one thing is for sure, for vertical equilibrium mg is equal to n1 plus n2, which means option C is very obviously correct. Now suppose we consider torque about these 2 points. Let's call this point A and this point as B. So if we consider torque about B, then about B, both mg and ma0 are producing torque in the clockwise sense. Okay, so that means the total normal reaction, that means about B is equal to, let's call this as tau about B, and due to the total normal reaction, this must be equal to ma0 into the moment arm, and that will be, if the total length is, let's say, height is h, then this height is going to be h by 3. So torque of the total normal reaction about point B is going to be equal to ma0 into this height h by 3 plus mg into whatever its length L by 2, side length L by 2. This is the torque of normal reaction about point B, whereas torque of normal reaction about point A, if I look, it is equal to the difference of the two, right? So if there is normal reaction, then that is going to be equal to the torque about A of that normal reaction is the anti-clockwise sense. So that means this torque is equal to mg L by 2 minus ma0 h by 3. Now it's very clear that torque of normal reaction about A is less than torque of normal reaction about B, and which means that the effective line of action of normal reaction is somewhere on this side, right, left of center, and that will happen only if N1 is greater than N2. Okay, if the total normal reaction is effectively acting through this part, then it means that normal reaction on the left part is greater than normal reaction on the right half. So based on this, if we work out, option A would be correct. N1 is not equal to N2. In fact, N1 is greater than N2. And if N1 is greater than N2 and N1 plus N2 is mg, then that means N1 is also greater than mg by 2. So option B is also correct. Well, that means for question 11, options A, B and C are correct. Let's move on to the next question now. Now, based on the same paragraph, question 12 says, if applied force F is large enough to just tilt the plate, then, well, if F is large enough to tilt the plate, then the total normal reaction would have shifted to the right corner, right? So here is total normal reaction, and here is F, and of course mg is acting through the center of mass, and ma0 is also acting through the center of mass, the pseudo force towards left. And we can see that if I take torque about this point, this height will be, this height h, we can find its value now. H is equal to L sine 60 or L root 3 by 2. So we have, in the clockwise sense, is torque by F. So F into L root 3 by 2 is equal to mg L by 2. This length is L by 2 plus ma0, and this height is 1 by 3 of L root 3 by 2. So it's by 3 into L root 3 by 2. Let's simplify. This gives us F root 3 is equal to mg plus ma0 by root 3, right? L by 2 goes everywhere, so okay, this is what it is. And the value of F itself is coming out to be then m into a0 by 3 plus g by root 3. If we look at the options, well, it is matching with option A. So option A is correct. B will be incorrect. And let's also look at statements given in C and D. C says vector sum of torque of weight and force F is 0 about obstacle. Weight and F. No, it's not correct, because we have to also consider torque of the pseudo force ma0. So if we consider all three, then the torque would be 0. Let's look at statement D. It says vector sum of torque of weight and force F is non-zero about obstacle. This is correct, because vector sum of these two torques in magnitude is equal to torque produced by the pseudo force. So D would be correct. So that means for question 12, options A and D are correct. Let's move on to the next question now. Question 13 says, if Nx and Ny are the contact forces by obstacle and floor respectively, when applied force is equal as calculated in question 12, then, okay, so Nx is the contact force by the obstacle and Ny is the contact force by the floor. Well, and the force F is just enough to tilt it. So we draw the situation once again. We have F acting here, whose magnitude we found in the previous question, and there is the pseudo force ma0, and the normal reaction is shifting here, right? This is a normal reaction by the floor, so this is Ny, and the normal reaction by the obstacle is this. Let's call it N. In fact, it's been called Nx. So we can see that, and of course there is mg. So it's very clear that Ny is equal to mg, and Nx is equal to F minus ma0, because then ma0 plus Nx is F. So Nx is equal to F minus ma0, and in the previous question we found the value of F. If we put that value of F, we find that Nx is equal to m into g by root 3 minus 2a0 by 3. So that means options B and option A are correct for question 13. Let's move on to the next question now. Well, now we have the next para, which says a container having ideal liquid of density rho is made to accelerate in vertical plane with an acceleration g as shown. Consider 3 points A, B and C inside the liquid. Pressure at these points are PA, PB and PC respectively. This is the diagram given, and this is the direction of acceleration g, which is given to the container. Points A, B and C have been shown here. Question 14 says, if liquid is in static condition with respect to vessel, then PC minus PA is this much. Well, let's evaluate. And to evaluate, what we do is we resolve this G into its horizontal and vertical components. So the horizontal component will be G cos 37 degree, which is 0.8 G or 4 G by 5. And the vertical component will be 3G by 5. Now, if we consider C and A, so PC will be clearly equal to PA plus rho, and then G effective in vertical direction becomes G plus 3G by 5. So that means it is equal to G plus 3G by 5 into H, and which gives us PC minus PA is equal to 8 rho GH by 5. So option A is clearly correct. Let's evaluate then PB minus PA, and before evaluating PB minus PA, let's find PC minus PB. These 2 points are at same level. So the pressure difference is due to the horizontal acceleration, which is 4G by 5. So this is equal to rho into 4G by 5, and this length L. Okay. Now in this triangle there is a relation between H and L. We can see that tan 37 degree is L by H, and tan 37 degree happens to be equal to 3 by 4. This is equal to L by H. So H can be replaced by 4L by 3. Okay. And further, PC minus PB is this 4 rho GL by 5. Let's say 4 rho GL divided by 5. That's the value of PC minus PB. Now we are interested in PB minus PA. So for doing that, if I call this equation 1 and call this equation 2, we can subtract equation 2 from equation 1. So that will give us PB minus PA, and we are subtracting this from this. So that is equal to 8 rho G by 5 into H. Now H is 4L by 3 minus, we have 4 rho G L by 5, 4 rho G L divided by 5. Let's see how much this comes out to be equal to. This is 15 and this is 32 minus 12 into rho GL, and which simplifies to 20 by 15 rho GL, which further simplifies to 4 rho GL divided by 3. So that means option C is also correct. And well, is it true? The option B, if we put L as 3H by 4, this is also coming out to be equal to rho GH. So that means option B is also correct. And it's clear that since horizontally the container is accelerating towards right, PB will be less than PC. So option D is also correct. So that means for question 14, all the options A, B, C and D are correct. Let's go to the next question now. Question 15 says, if free surface of liquid makes an angle alpha with horizontal, then alpha is tan inverse 1 by 2, alpha is tan inverse 2. Net force on any small cross section of liquid will be perpendicular to the surface, and net force on any small cross section of liquid will not be perpendicular to the surface. Well, we know from the property of fluids that option C would be correct, that net force on any particle of liquid will be perpendicular to the surface of the liquid. Okay. this is true. So option C is correct, and of course we shall evaluate, and which means option D is incorrect. Now to evaluate the angle that the free surface makes with horizontal, what we do is we can take a particle of liquid on the surface. So say this is the surface at angle alpha. Now if I consider this particle, it's of mass m, then one force is mg acting on it, and the other force is, if I again draw the horizontal line, so there is this pseudo force mg acting, and this is the horizontal line. So with the horizontal line, this angle is 37 degree. So there is this pseudo force mg acting here. Now if I resolve this pseudo force into horizontal and vertical components, its horizontal component will be 4 mg by 5, and the vertical component is 3 mg by 5. So that means on this particle, if we look at these two forces alone, then the vertical component is mg plus 3 mg by 5, or 8 mg by 5, and the horizontal component is 4 mg by 5. Now the resultant of these two forces will be perpendicular to the surface. That is the whole idea. So if I draw resultant of these two forces, this is normal to the surface, right? And this angle, we can see that if this angle is alpha, this angle is also alpha, and tan alpha, we can see that is equal to 4 mg by 5 by 8 mg by 5. That means it is 1 by 2. So alpha is tan inverse 1 by 2 is correct. So that means for question 15, options A and C are correct and B and D are incorrect. Let's go to the next question now.